This video will cover two sample problems on the moles of compound two-step problem. In question 1 through 5, they are all asking your number of molecules of your compound. It's just like the other problems that we did with sample problem 6, where we were finding our atoms, but instead of atoms, we have molecules. They're going to be set up and solved the same way. So let's take a look at number 1. So number 1 wants to know how many molecules, and remember I abbreviate molecules MOLC, of HCl we have if we have 72 grams of HCl. So we go to our mole diagram. So this time we're starting in mass. And again, there's not a direct path going from mass to number of particles, so this is why it's considered a two-step. So we'll go mass to moles using our periodic table, then moles to our number of particles, which is our number of molecules down here using Avogadro's number. So the box we're starting in will go in the bottom of our equality. The box we're going to will go in the top of our equality. So grams of HCl go in the bottom because we're starting in mass, and moles of HCl will go in the top. And since the substances is the same, it's 1 mole, and we're going to calculate the molar mass of HCl. So we look up the mass of hydrogen, we look up the mass of chlorine, add them together, and that comes up to be 36 grams. Now we're into our second step. So we're here in moles, so that goes in the bottom of our equality. We're going to number of particles or molecules that will be in the top of our equality, and we will use Avogadro's number. So moles is the box we're starting in. It goes in the bottom. Molecules and Avogadro's number will go in the top, the 6.02 times 10 to the 23rd molecules of HCl. Since the substances are the same, it's to 1 mole. So we will take the 72 times 1 times the 6.02 times 10 to the 23rd, and that comes out to be 4.3 times 10 to the 25th, divided by the 36 times 1, which is 36, divide those numbers there, and our answer comes out to be 1.2. So our answer comes out to be 1.2 times 10 to the 24th molecules of HCl. So our moles cancel, our mass cancels, and we're left with molecules of HCl. So number 1 is the sample for problems 2 through 5. Let's take a look at question number 6. Number 6, we're just going in the opposite direction of our mole diagram. We're going from number of particles to moles, our first step, then moles to our mass, our second step. The box we start in will go in the bottom, which will be our number of molecules, and the moles will be in the top of our equality. So in this problem, we want to know how many grams we have of chlorine, and we are given 6.02 times 10 to the 23rd molecules of Cl2. So since we're starting in molecules, we will put molecules down in the bottom of our equality, which will be Avogadro's number, the 6.02 times 10 to the 23rd molecules of Cl2. and the box we're going to, which is moles, will go on the top. And since the substances are both chlorine, it's to 1 mole. Now we're going to go moles of Cl2 to our mass in grams of Cl2. The box we're starting in our mole diagram is moles. The box we're going to is grams, so it goes on the top. Moles will go on the bottom. Since the substances are the same, it's 1 mole, and we look up the mass of chlorine, which is 35, but we have 2 chlorine, so our mass is 70. So we take the 6.02 times 10 to the 23rd times 1 times 70, and that comes out to be 4.2 times 10 to the 25th. We take the 6.02 times 1, 6.02 times 10 to the 23rd times 1, which is 6.02 times 10 to the 23rd. Divide those two numbers out, and we get 70 grams of Cl2. So number 6 is a model for 7 through 10.